Hi students, let us continue with the discussion, that is structures and pointers. Today's topic is structures and functions. So as we all know, we can use or we can pass any integer or float data types as the argument for the functions. In a similar way, we can also use structure variables as the arguments to any function. So C language provides passing structures as arguments or parameters to any functions. So till now we have been using like integer or any floating data types as the argument for any function. But in today's class we are going to use structure variable as the argument for any function. And these structure values can be passed to a function by value or by reference. So in the previous module we have seen that we can call a function by value or by reference. There are two ways of passing a value to a function, that is by value or by reference. So in the same way we can also use structure values as a argument to a function by value or by reference. So there are different methods by which values can be passed to a function. The first method is to pass each member of the structure as an actual argument. So instead of passing the whole structure, we can use individual member as the separate argument and we can pass it to the function. And the second method is, instead of taking individual member as the separate argument, we can use the entire copy of the structure and pass it to the function as the argument. The syntax is given in the next slide. So we know that our function contains three different parts: function declaration, function call and function definition. So let's see the syntax for function declaration. Again, function declaration contains three parts: return type, function name and its arguments. So here the only difference in this case is, inside the parenthesis, that is set of arguments, we are going to specify or we are going to use the structure as the we are going to use structure variable as the argument to this particular function. So let us take one example where display is the function name and it returns nothing. So that's why the return type of display is void. Void means it is not going to return anything, and the argument it is taking is structure student. So the data type of this particular variable S1 is student structure. It is not a simple variable. It is not integer or float or double. It is of type student. It is a structure. So once we have declared the function, the next step is to call the function. So again we know that if a function is returning something, then we need one variable which holds that return value. Since this particular example which we have taken is not returning anything, that's why we are not going to have any extra variable which will hold this value. That's why we can just say that function name followed by the string variable name. So in this example, the string variable name is nothing but S1. So we are not going to specify the whole keyword and the data type student. We would have to just say S1. Okay, we are not going to provide full details of the student structure. and this particular example calls the function name display. This function display called by passing the structure variable s1 of type student. Here the type of s1 is the student structure. And once we have called that function, the next step is to define the function, that is function definition. Again, we know that function definition contains two main parts, that is function header and the function body. Again, in function header, it is very similar to the function declaration. The only difference here is there is no semicolon at the end. So for function definition, there is no semicolon at the end, whereas in function declaration there is a semicolon at the end. That is the only difference between function header and the function declaration. The rest all syntax is same. And the function body contains different set of statements. This statement is nothing but the actual work that will be done by the function which you have defined. And finally, if there is any return value which it is going to return, then you will have to specify that return statement. Otherwise, you can skip this part. Okay. The example for this is void display. So display is a function which does not return anything, which simply prints the student name, and it is going to take the argument as structure student s1. So s1 is the variable or the argument which the display function will take, and its data type is student structure. And what is the work of this display is, it is just going to display the student name. It does not return any particular value. While displaying the name, you would have to say s1 dot name. Why not just name? Why would we have to say s1 dot name? Because name is a member of the structure. As I have told, if we want to access the member of the structure, then I have to access it through the variable. That's why I have to say s1 dot name. I cannot simply say name. Okay. So this is the example for reading a student roll number, name and marks as a structure, and we are going to pass this whole structure as the argument to a function. So function name is given as display. So what we are doing is, we have to construct or we have to define a structure called student, which takes three members: roll number, name and marks. And we are going to pass this whole structure as the argument to a function called display. So we are not going to pass these members individually. Instead of passing these members individually, we are going to pass the whole structure to a function. Okay. So before starting the definition of the function, I would have to create my student structure. So the first thing I will have to do is create a student structure with three members, that is roll number of a student, name and then marks. So once you have created the student structure, the next step is to define the function. Declare the function. It is not the definition, it is the declaration of the function. So once you have created the student structure, the next step is to declare the display function. So this display function is going to take the variable s1 as the argument. If you observe it carefully, this s1 is of type student structure, which we have defined here. Okay, and once we have declared the function, we have to start with the main function. So inside the main function, I have created a variable name S1 of type student structure. So S1 is the variable which is of type student structure. Okay, and then I will ask the user to enter student roll number, name and marks, as I have already explained in the previous class. So the user will enter roll number, name and marks of a student respectively using keyboard. So in order to read the roll number, I have to say S1 dot roll number, because roll number is a member of the student structure, so I cannot access it directly. So I would have to say S1 dot roll number. Then for name, I would have to say S1 dot name and then S1 dot marks. So this roll number will get stored in %D and name will get stored in %S and marks will get stored in %F. So once you have given all the values, I am going to call the display function. So this display function takes the argument as the structure student variable which we have declared here, that is S1. So S1 is the whole structure, it is not a single value or it is not a single roll number or single name or marks, it is the whole structure. So what we are exactly doing here is we are passing a whole structure as the argument to the display function. So once the control comes here, it stops and it will skip to the display function. So this is the definition for display function. As I have told, this contains three parts. One is return type. Here the return type is void because it is not going to display, it is not going to return anything. And the second part is display function name, and the third type is the set of arguments. Here the argument is nothing but a structure. Okay. So inside this display function, I will just display the roll number, name and the marks of a student. By using printf statements, I am going to display these three values. Okay. And the output for this particular program is enter the student roll number, name and marks. So that is from this particular printf statement. So after this printf statement, once the control comes here, it will pauses for the user to enter roll number, name and marks. So once the user gives the roll number, name and the marks, that is 1, Peter and 96, that value will be passed as the argument for the display function. So this particular function will display these three values. So these three outputs are nothing but the output of this particular function. So this particular printf statement would display roll number, that is S1 dot roll number, because whatever the roll number we have given is being stored in S1 dot roll number. So again, in order to fetch roll number, I have to say S1 dot roll number. And then in order to display name of a student, I would have to say S1 dot name, and for marks I would have to say S1 dot marks. Okay. The next concept we are going to study is copying of structure variables. So like other variables, how we copied other variables, that is if there are two integer variables a and b, I can copy the value of b to a, correct? If b contains 2, number 2, if I want to copy the content of b to a, then I would have to just say a is equal to b. Using assignment operator, I can copy the value of one variable to another variable. In the same way, I can also copy the value of one structure variable to the other structure variable, again using the assignment operator. So if you see, if I want to copy the content of S2, S2 is a structure variable. If I want to copy the content of S2 to S1, then I will say S1 is equal to S2. So the content of S2 will be copied into S1. So this particular expression will be treated as like this. So the compiler will individually copies these members into that particular variable members. So S2 dot roll number will be stored as S1 dot roll number, and S2 dot name will be copied onto S1 dot name, and then S2 dot marks will be copied onto S1 dot marks. You don't have to individually specify those values. So let us see the example which copies the information of one structure to another structure variable. Okay. Again, I have to create a student structure which again takes 3 members, and then inside the main function I will declare 2 variables S1 and S2 of type student structure. Okay. Then again using printf statement, printf and scanf statement, I am going to read the roll number, name and marks of student S1. Okay. I am going to read only one student's information. I am not going to read second student's information, because in S2 I am going to copy the contents of S1. That's why I would require only one student's information. So in order to copy S1 dot roll number, S1 dot name and S1 dot marks into S2 dot roll number, S2 dot name and S2 dot marks, I would have to just say S2 is equal to S1. So once the compiler sees this particular expression, it knows that it has to copy all the contents of S1 to S2. Okay. So if you display these individually, then you will get to know what actually has happened. Now in this particular place, that is S2 dot roll number, S1 dot roll number has been copied, and in place of S2 dot name, S1 dot name has been copied, and in place of S2 dot marks, S1 dot marks have been copied. Okay. So if you display them individually, then you will get the same result as of S1. So S2 is nothing but a copy of S1. The next concept we are going to study is comparing of structure variables. Unfortunately, C language does not permit any logical operations on structure variables. So I cannot completely compare the structure variables. that is S1 equals to S2. If I want to check whether S1 is equal to S2, then I cannot say S1 equals to S2, because there is no assignment operator permitted in structure variables. And also this particular operation cannot be performed, that is S1 is not equal to S2. So if I want to check whether S1 is not equals to S2, then I cannot say S1 not equal to S2. I cannot perform this operation. If at all you want to compare two structure variables, then you have to compare their members individually. Even though you cannot compare the complete structure, there is a provision for you to compare their members individually. That is, if I want to compare whether the roll number of S2 is same as that of the S1, then I can say S1 dot roll number is equals to S2 dot roll number. This is permitted. Individual operation is permitted, but the complete set of operation is not permitted. So if I want to check whether S1 is equals to S2, then I have to compare their members individually, like S1 S1 dot roll number equals to S2 dot roll number, S1 dot name equals to S2 dot name, S1 dot marks equals to S2 dot marks. So if at all these members are equal, then only I can say S1 is equal to S2. Otherwise S1 is not equals to S2. Okay, yeah, here there are two examples given. The first example is from that is comparing the structure variables completely, that is S1 equals to S2. If I try to perform this operation, then the compiler will give you an error. It will say this operation is not permitted. This is not possible, because complete structure variable comparison is not permitted in C language. So if I try to execute this particular program, the first program, then I will get an error. I will not get the end result. I will get an error saying comparison is not permitted on complete structure, whole structure. And in the second example, instead of comparing the complete structure, what I have done is I am comparing their members individually. If S1 dot roll number equals to S2 dot roll number and string compare, I have used a library function called string compare, because name is a string. So I cannot directly say S1 dot name equals to S2 dot name. No. If I want to compare two strings, then I have to use different method, right? That is, I have used a library function called strcmp, S1 dot name comma S2 dot name equals to 0, and S1 dot marks equals to S2 dot marks. So if all these three are true, if all these three conditions are evaluated to true, then only I can say that both the students' information are same, or both the students are same. All of these conditions should hold true. Then only I can say both are same. If any one of them holds false, then I cannot say both are same. Okay. So if the condition is true, we know that AND operation will give us the result as true if and only if all the inputs are evaluated to true. So if s1 dot roll number equals to s2 dot roll number is evaluated to true, as well as string comparison of s1 dot name to s2 dot name is equals to 0, it means that there is no difference between s1 dot name and s2 dot name, and also s1 dot marks equals to s2 dot marks. Even if it is evaluated to true, then only if condition or if statement will be executed that says both the student information are same or both the students are same. Otherwise it will display that both the students are not same. Okay. Yeah. So my first program will give you an error because we are trying to compare the whole structure variables. That is not permitted in C language. But in case of second program, the result would be either both the students are same or both the students are not same. Because here I am comparing the individual members of two structures. So this is permitted in C language. That's why I will get the end result. So if at all you want to compare two structure variables, then you have to compare their members individually. This is very important. Okay. The next concept which we are going to study is operations on individual members. So what are the different operations that we can perform on individual members? So like on integer variables or float or double variables, we can perform addition or any logical operations, or you can also perform subtraction, arithmetic operations, relational operations. So different operations you can perform. So in a similar way, you can also perform some of the operations on individual members of structure variable. You cannot perform operations on complete structure variable. You can perform operations on individual members. So if I want to add two variable information like roll number, if I want to add marks of two students, then I will have to say s1 dot marks plus s2 dot marks. I cannot say s1 plus s2. This is not permitted. S1 and S2 are complete structures, and S1 dot marks and S2 dot marks are individual members. So some of the operations which I can perform on individual members are say arithmetic, logical, relational, increment, decrement, bitwise, etc. And also we can perform some of the string operations like compare, concatenation, or finding the length, if at all our structure which we have defined is string structure. And as we all know, we can perform member operator also, that is dot operator, and this operator has the highest precedent among all the operators. It means that if at all dot operator is present in the expression, then you have to evaluate that operator first, then only you can evaluate the other operators. So there is one example where we are trying to find the average of two students' marks. Okay. So again you have to create structure student, and then inside the main function